So now we're going to take a quick look at how the photodiode works. I'm going to explain it. You can't really see from this diagram. But in case, a photodiode is different than a light-dependent resistor. It doesn't have a resistance, which would mean that it has a different amount of current flows through it based on supply voltage. Instead, it actually allows a certain amount of current to flow through it based on how much light is falling on it. It's kind of like a little current source. And so if it's bright enough, maybe you'll get more current than you desire. So what you can do is set a maximum current with a resistor. It will have a maximum, or whatever current it will set based on the supply voltage will basically be your maximum current. And this is where you could take a current measurement if you wanted to. But in any case, as long as it is dim enough, the photodiode is going to limit the current below what the resistor is. And it's going to set that current even if the supply voltage changes quite a bit. So now here's a simple circuit to get you more familiar with the 555 timer and maybe even the light dependent resistor right there. But no matter what part number you are using, the reset pin should be the most powerful input of the 555 timer. We have pin number 2 right here that we just use a resistor to connect it to ground, and that keeps a low input. That means pin number 2 wants to keep the output high. But pin number 4 is a more powerful input right there. So if you get really close to 0 volts, in this case a bright enough light falling on the light dependent resistor, then it's going to force the output low. And when you take away that bright light, then it's going to stop holding the output low and let pin number 2 set the output high again right there. You can adjust sensitivity with this resistor right there, but you have to get pretty close to 0 volts from my testing to get a low input to pin 4. So now we got another 555 timer circuit. Gets you more familiar with how it works, and maybe the light dependent resistor right there. And this should apply no matter what version of the 555 you're using. Probably a NE555 or a Micro A555. But we have pin number 2 right here. It always wants to keep the output high, which in this case would keep the LED off. Pin number 4. So we have a light dependent resistor, but the pull down resistor there wants to keep a low input to pin 4. A light on the light dependent resistor will prevent that from happening. But you get it dark enough, then you get that low input to pin 4 right there. It will overpower 2. 4 is more powerful than 2. Reset and trigger right there. So when you get a low input there because it's dark enough, then the output will be low and the blue LED will light up pretty well. So now these two drawings, we have a pull-up light dependent resistor over here when it comes to the voltage divider. You can see the one on the left here has a pretty low value pull down resistor right there. So this is going to want to stay a low voltage. We have to get a pretty bright light on the light dependent resistor to really pull the voltage up. Next to it, we used a much higher value resistor right here. So it doesn't pull down near as hard as the 1K resistor did right there. We don't need as much light on the light dependent resistor right here to pull the voltage up. So it's really that simple to adjust sensitivity. Of course, you don't instinctively know how much light you're going to need. You just try different value resistors and adjust the light level until you get the output voltage that you desire based on the light level falling on the light dependent resistor. So now we're going to talk about the sensitivity of a voltage divider when you have the light dependent resistor on the low side. So first we'll look at when your fixed value resistor on the high side is a low value. So it wants to connect to the positive supply, you know, a relatively low resistance there. And so that's going to make it so you need much brighter light on the light dependent resistor to give you a lower voltage at the output right there. Now, in contrast to that, we have a somewhat high value resistor over here to the positive supply. So you don't need near as much light on the light dependent resistor down here to get a lower voltage. So that's how you adjust the sensitivity. And the higher value resistor, harder it's going to be positive, much easier for a given light level to get a low voltage at the output. Whereas when you got a lower value towards a positive supply, you need a whole lot more light to fight against that and give you a lower output voltage. So now we have kind of a set reset circuit with the 555 timer and a couple light dependent resistors. We'll zoom in, and there's two things to always be aware of when it comes to pin 6 and pin 2. Pin 6 wants 2/3 of the supply voltage or more to set the output low. Pin 2 wants 1/3 of the supply voltage or less to set the output high. So there's a middle ground region between 1 and 2 where the output could be in either state. We get more light on that light dependent resistor than that one. We'll get a high input to pin 6 if we get enough. And again, that's going to set the output low. And if we get equal light again, it's going to stay there. But then if we get brighter light on that light dependent resistor to pin 2, then it's going to set the output high right there. The red LED will light up. Again, if it equalizes again, it's going to stay in that state right there. So middle ground, when the light's pretty much equal right there, the output will not change.